Welcome. Shoot. Hang on. Let me add myself to the stream here. Okay, now you can see me. Hey, welcome everybody to another episode of What's Up with the Universe. I'm your host, Eli Hoo, and I don't know why I am lagging right now because I have a solid internet connection. Okay, well, it's been a while, but we are going to be talking about something about that big old gray ball in the sky. I mean, Doctor Who claims it's an egg, but in reality, it's actually the moon. Yes, we are going to be talking about the moon, the brightest and largest object in our night sky. And I want to welcome everybody who's in the live chat right now and who's watching on the restream, by the way. Sorry. Here we go. Oh, come on. It's been a while since I did these functions here, so where am I? Come on. It's been a while. Here we go, I think. Nope. Okay. Sorry. Yeah, it's been a while since I streamed, so. If you're new to the channel, welcome. I just want to remind you, if you like what you see, hit a thumbs up. If you don't, hit a thumbs down. I'm not forcing you to do either or. It's your choice. And if you want to help support science, just my tips are to write down there on the bottom. So today we are going to be talking about the moon. And yes, Mr. Miles, the moon. It is called the moon, but also it is called Luna. In Latin, the moon is called Luna. Richie Poole is correct. It is the brightest, largest object in our night sky that we can see. I mean, the moon makes a more livable planet by moderating our home's planet wobble on its axis, leading to a relatively stable climate. It also causes tides, creating a rhythm that has guided humans for thousands of years. I mean, the moon was likely formed after a Mars-sized object collided with Earth several billion years ago. Earth's moon is the only piece of Earth where humans have set foot on so far. I mean, it's our only natural satellite. It's simply called the moon, because people didn't even know other moons existed until Galileo discovered 4 other moons orbiting Jupiter in 1610. With a radius of about 1,080 miles or 1,740 kilometers, the moon is less than a third of the width's Earth. I mean, if the Earth was the size of a nickel, the moon would be big as about the size of a coffee bean. The moon is an average of 238,855 miles away. Yes, I did math. That's 384,400 kilometers. That means 30 Earth-sized planets could fit between Earth and the moon. Yes, it is very far away. I mean, the moon is slowly moving away from Earth, getting about 1.5 inches or so farther away each and every year. I mean, long before the first humans ever gazed up into the velvety blackness of the night sky, the moon was young and very fresh-faced. So we'll talk about the moon here. There was a lunar eclipse, and I did not get a chance to see it because I was suffering from the astronomer's worst nightmare. Clouds. Yes. Okay, what was I talking about? Oh yeah, the early days of the moon. Before the patchwork of the inky stains called the Man in the Moon, before that brilliant starburst pattern that called raised craters decorated the surface, before a colossal crash turned 1/5 of the real estate into the South Pole Aitken Basin, let's fast forward to the present. And the moon's once smooth contour appears flawed and disfigured, punished by explosive volcano eruptions and raining interstellar objects that bombarded the surface over the eons. I mean, I'm going to show you some animations here. Some of these are the clearest views of the moon. Some of these are courtesy of the NASA's LRO, the Lunar Reconnaissance Orbiter. This is what scientists have basically, with all the research and speculations and stuff, about how the moon was actually formed. fields of dark red rock left by volcanic eruptions, mistaken for huge seas, were named Maria. Some of them make up the man on the moon's face. And that is our moon. Yes, it is. What happened to my thing here? Oh, here we go. Okay. I'm like, wait a minute. I mean, as large as moon craters go, the giant bullseye called the Oriental Basin is thought to be young, like the moon's last major body blow. And I'm not sure what's going on here with my little slideshow. Here we go. Come on. Here we go. I mean, a lifetime of plummeting by space objects, large and small, has given the moon its very familiar pockmarked look. The sun beats endlessly on the peaks of the southern pole's Shackleton crater, but its cold depths may not have seen light for at least 2 billion years. I mean, because Tycho crater seen here is young, the 1 mile tail peaks at least its center at its sharp and, of course, is very imposing. Although the moon has remained largely unchanged during the human history, our understanding of it and how it has evolved over time has evolved dramatically. I mean, thanks to new measurements, we have new and unprecedented views of its surface, along with new insights into how it and other rocky planets in our solar system came to look the way they do. I mean, let's take a little tour of the moon itself, okay?
To nearly everyone, the moon appears to be a sterile, gray, unchanging world. But while the moon has remained largely unchanged during human history, our own understanding of it has evolved dramatically. Thanks to new observations, we now have not only unprecedented views of its surface, but a whole new tour of the moon that shows how both it and other rocky planets in our solar system have been shaped over billions of years. We'll start with one of the largest impacts, Oriental Basin, a feature that's as wide as the distance from New York City to Cincinnati. Using new elevation measurements, we can clearly see the effects of what is likely the last giant impact event in lunar history, with its outer mountain rings rising many kilometers above the lowest points inside the crater. The interiors of some craters in the moon's polar regions, like Shackleton, haven't seen sunlight in over 2 billion years. However, new measurements have created our best yet maps of these types of craters, allowing us to see deep into the shadows of this surprisingly young-looking impact crater in the south that's more than twice as deep as the Grand Canyon. Some impacts are invisible for other reasons. Although the ancient South Pole Aitken Basin is difficult to see from orbit because it is so large, new LRO topography maps reveal the largest impact basin in the Earth-Moon system, measuring several kilometers in depth and around 2,500 kilometers in diameter. Only the Hellas Basin on Mars rivals it in size. One of the youngest large-scale impacts on the Moon is the Tycho crater. This fresh crater may have formed only 108 million years ago, when dinosaurs roamed the Earth. We now also have an extreme close-up view of the crater's central peak, revealing a mountain with sharp edges, building-sized rocks, and a central boulder about the size of a baseball stadium. The Aristarchus Plateau is another recent lunar formation that has long interested scientists and astronomers. The crater itself formed in the same era as the Tycho crater, and what appear to be snaking river valleys were actually carved by ancient lava flows. Next, we arrive at Mare Serenitatis on the near side of the Moon. In December of 1972, the crew of Apollo 17 landed in the Taurus Littrow Valley, marking the last time humans have visited the surface of the Moon. With images from LRO's narrow-angle camera, we can clearly see the evidence of that visit. In this image, you can easily see the base of the lunar lander, along with the lunar rover, parked far from the blastoff zone. You can also clearly see the astronaut trails and the wheel tracks left on the lunar surface. We now head to the far side of the Moon, which cannot be seen from Earth. Our first stop is the Compton-Belkovich region, which shows evidence for young volcanic activity in the far side highlands. This feature is unique not only because it is isolated from other volcanoes in the area, but also because it is located nowhere near the Maria, where volcanoes are usually found. Also, on the far side we find the Jackson crater, which, like the Tycho crater on the near side, has an extensive and complex ray system. In fact, this crater is often considered to be like a twin to Tycho. Finally, the Tsiolkovsky crater stands out as an excellent example of a far side crater filled with a sea of ancient lava, known as a mare. It is particularly interesting to scientists and other observers because of its isolation from other similar craters, as well as its beautiful central peak. As we continue to study the Moon, our understanding of it improves, giving us new insights not only into how it has evolved over time, but also how other rocky planets in our solar system have come to look the way they do. With new missions, new instruments, and new technologies, we will continue to improve our knowledge of the Moon and better understand the history of our solar system.
And as we have a NASA site of the tour of the Moon, let's actually talk about the Moon's orbit around this little rocky planet that we call Earth. The orbit of the Moon in 2021, viewed from the North Pole of the ecliptic, with the vernal equinox to the right. The size of the Earth or Moon are exaggerated by a factor of 15, 20, or 25, depending on how large you have your screen right now. From this bird's eye view, it is somewhat easier to see that the phases of the Moon are an effect of the changing angles of the Sun, Moon, and the Earth. The Moon is full when the orbit places it in the middle of the night sky outside of the Earth. First and third quarter of the Moon occurs when the Moon is along the day/night line of the Earth. The first point of Aries is at the 3 o'clock position in the image. The Sun is in the direct at the March equinox. Of course, I'm going a little faster than my little animation here, but you know how to tell time, right? You can check my freezing animation around 103 mark, or by freezing the full animation with the time stamp near the March 20th. This direction serves the 0 point for both elliptical longitude and right ascension. The North Pole of the Earth is tilted at 23.5 degrees toward the 12 o'clock position on top of the image, which I just missed. The tilt of the Earth is important for understanding why the North Pole of the Moon seems to swing back and forth. You can see both the orbit and the gyroscope, Moon, and as you can see it orbiting the Earth itself. The widest swing happens when the Moon is at the 3 o'clock and 9 o'clock positions as it's coming up. When the Moon is to the left, when the Moon is at the 3 o'clock position, the ground we're standing on is tilted to the left when we look at the Moon. At the 9 o'clock position, it's tilted to the right. The tilt itself doesn't change. We're just turned around looking in the opposite direction. Okay, let's talk about some subsolar points on the Moon. This animation right here is of the subsolar and sub-Earth points. The Moon's North Pole, equator, and meridians are easily indicated by the lines. Subsolar and sub-Earth points are the locations on the Moon's surface where the Sun and Earth are directly overhead at the zenith. The line pointing straight up at one of these points will be pointing toward the Sun or the Earth. The sub-Earth point is also the apparent center of the Moon's disk as observed from the Earth. In this animation here, the blue dot is the sub-Earth point, and the yellow cone is a sub-solar point. The lunar latitude and longitude of the sub-Earth point is a measure of the moon's libration. For example, when the blue dot moves, I apologize. I'm drinking hot chocolate at the same time. Okay. The lunar latitude of the longitude of the sub-Earth point is measured by the moon's libration. When the blue dot moves to the left of the meridian, the line at 0 degrees longitude, an extra bit of the moon's western limb is rotating into view. And when it moves above the equator, a bit of the side beyond the North Pole becomes visible. At any given time, half of the moon is in sunlight, and the subsolar point is the center of its lit half. Full moon occurs when the subsolar point is near the center of the moon's disk. When the subsolar point is somewhere on the far side of the moon, observers on Earth see a crescent phase. I apologize. Yeah, I apologize about the coughing, guys. I was taking a drink of hot chocolate, and my chocolate went down the wrong windpipe, so I apologize, people. Okay, so how far away is the moon? Well, this animated excuse me. This animated diagram here, it shows the distance from the moon to the Earth, and the size of the distance to true scale and the lighting and Earth tilt are correct, by the way. And this is not even playing. Why is the animation not playing? Okay, there it is. It's playing. The moon's orbit around the Earth isn't a perfect circle. The orbit is slightly elliptical, and because of that, the moon's distance from Earth varies between 28 and 32 Earth diameters, or about 406,700 kilometers in each orbit. The smallest distance is called a perigee. See, unlike you, LDG gets a wrench because he's a perigee. He's a small little distance from everybody. Okay, basically, perigee, it comes from Greek meaning near Earth. The greatest distance is called the apogee. The moon looks largest at the perigee because that's what's close to us. I can do that, Bob Mike. The animation basically here is it flows in a imaginary line connecting the Earth and the moon as it sweeps around the moon's orbit. From this vantage point, it's easy to see the variation in the moon's distance. I mean, both distance and the size of Earth moons are to scale in this view. And the HD resolution frames, the Earth is in 50 pixels wide, the moon is in 14 pixels wide, and the distance between them is about 1,500 pixels on an average. Excuse me. For all you computer nerds out there who like to mess around with your window size, okay? Also note that the Earth appears to go through phases just like the moon does. For someone standing on the surface of the moon, the sun and the stars rise and set, but the Earth does not move in the sky. It goes through a monthly sequence of phases as the sun angle changes. I mean, these phases are opposite of the moon's. During the new moon here, the Earth is as full view as it is from the moon. I mean, why can I not talk today? Okay. Excuse me, people. Excuse me very much. Excuse me. Okay, my overlay just got side-shorted here for some reason. This is not working right. I apologize. I have some images here about phases of the moon explaining exactly what they are. And for some reason, it's not showing. Let me try to redo this here again. I apologize. Here we go. The phases of the moon. Okay, finally, I can show you this now. These are some images of an example of each type of the moon phases. The moon phases, they have names in English. New, full, and quarter phases occur on specific days, while the crescent and gibbous phases are the transitions between these points and multiple days. These quarters are so named because they occur when the moon is only 1/4 or 3/4 of the way through its cycle of phases. Some people find this confusing, though, since visually they are half moons. It might be helpful to remember that the visible half of the moon's disk is really only 1/4 of its spherical surface. This right here image is the waxing crescent. This is usually visible toward the southwest in the early evening sky. This right here is the first quarter. It's usually visible high in the southern sky in the early evening. This moon phase is called the waxing gibbous. This one is called the full moon. Usually rises around sunset, high in the sky around midnight. It's visible all night, sometimes in the daytime. This right here is called the waning gibbous. This one is called the third quarter. It usually rises around midnight, visible to Earth in the sunset, after sunset. This one is called the third quarter. And the second to last one is called the waxing crescent. And of course, we have the full moon. The new moon. New moon. I mean, by the modern definition, the new moon occurs when the moon and sun are at the same geocentric elliptical longitude. The part of the moon facing us is completely in shadow then. Pictured here is the traditional new moon, the earliest visible waxing crescent, which signals the start of a new month in many lunar and lunisolar calendars. And I want to thank everybody who decided to join me for the show today. Everybody joined me in the chat as we learned about our moon. So if you have any questions about the moon, leave them in the chat below in the comments. And don't forget to have the thumbs up or thumbs down button. I don't care. Either or. It's your choice. I'm not forcing you to do anything. But I just want to make sure to ask you a question. Are you looking up at night? Or do you ask yourself, hey, what's up with the universe? Thank you, everybody, for joining me.